So hello everyone, today we'll be knowing about multi-source BFS. This is a very important algorithm for solving many competitive programming as well as DSA problems. Also, there are many real life use cases for it. Uh, so let's understand the algorithm. So you'll be given a graph and you need to find most often cases, the query is related to distance from the source. So the standard BFS algorithm has a single source, right? Standard BFS algorithm has a single source where you start your BFS from. And the source which you consider is considered to be at level 0. The immediate next level is the level 1, after that level 2, and so on. But when it comes to multi-source BFS, you have either 2 or more sources. So the thing is quite simple. You should start BFS from both the sources. You should start BFS from both the sources. So the initial distance of this source is 0, and this source is 0. Why? You're measuring distance from the source, right? Measuring distance from the source. So what's the distance between the source and the source itself? Obviously 0, right? So the distance between the source and itself is obviously 0. So you'll mark that particular distance as 0. Next, coming to the next one. From this source from 0, what's the distance of 3? It's 1. What's the distance of 1? It's 1. If it was a single source BFS, the distance of 2 would be 2, right? This distance is 1, so this would be 2. But from this source, from 4, the distance of this source is 1. So this is the final output you get. If I write the distance of each of them in an array, it would be 0, 1. Okay, let me write the indices first. 0, 1, 2, 3, 4. 0 is a source, so distance is 0. 3 is at a distance of 1. 1 is at a distance of 1. 4 is a source, and 2 is at a distance of 1. So this should be the final output. Okay. The one variation would be printing these distances. That's the simplest variation. Otherwise, the questions may ask you to maximize some distance or minimize some distance or maybe anything. There are several problems on it. We'll be doing all of them. So let's see the code for it before we further move to some more problems. Let's see the code for it. It's very interesting. Same as BFS with some little twists. So hello everyone, we are back to VS Code, and I have already written the function for multi-source BFS. Like the function, I haven't written anything inside the function. It's an empty function for now. I have also written the main function and also given the same test case. So here if you see, it's the same test case 0 to 1, 1 to 2, and the same output I have given. So now let's start writing the code. Yeah. So now to get started, we would need a vector distance that would store the distance of each node from its source, its nearest source. Okay. So what would be the size of this vector? The size of this vector would be equal to the number of vertices. The number of vertices in number of vertices. Let's say it's n. So let's say there are n vertices. So it would be equal to adjacency list size. Adjacency list size is same as number of vertices. So it would be equal to n. Initially, let us take all the distance as -1 since none of them are visited. So we don't have a visited array here. The distance array also serves as the visited array. To enable this functionality, we would need it to be assigned with some other value other than 0. Because sources have the value 0, you need, and any values between 0 to infinity are valid, right? The worst case, if it's a source, the minimum value would be 0. Otherwise, it would be infinity. It could go to infinity all the way. Okay. So now we need some value which doesn't belong to this range, What could be that value? The first value that comes to your mind is infinity. You don't know how much it is. So obviously the first value that comes into your mind is -1. You can take any other negative value. It's absolutely fine. -1 just acts as a check. It's not something very specific that you need to take only -1 or something like that. You can take any negative value. It's absolutely fine. Now we have a distance vector. Once you have this distance vector, let us actually iterate through the adjacency list. Okay, let us iterate through the adjacency list and find out the sources. Okay, we already do have a sources array. So let's see. For auto source in sources has like the graph has 0 and 4 as sources, right? 0 and 4 are sources. So sources array contains all your sources. In my case, this array would contain a 0 and a 4. So iterate through the sources. We have discussed distance of source from its nearest source would be how much? It would be equal to 0, right? In the earlier graph, we saw that distance from the source to its nearest source is 0 because it's the distance of the node from itself. The distance would be obviously 0. So let's do that. Let's mark distance of source as 0. The distance of source as 0. And next, what would be the next step? We need to visit the neighbors of the sources, right? So let's push. Let's take a queue and push source into it. We haven't made a queue yet. Let's make a queue very quickly. Queue end queue. And yeah, queue is made. So currently my queue would have 0, 4. All right. And what would be the distance of 0 and 4? Distance of 0 and 4 would be the current configuration of my distance array would be 0 would have distance 0, 1 would have distance -1 since it's not visited yet, 2 would have -1, 3 would have -1 because it is not visited, 4 would have distance 0 because it's visited and a source. Now my queue has 0 and 4. While simple BFS now, while queue is not empty, my current node would be at q dot front. All right. My current would be at q dot front, and I would do q dot pop. Then I have my current node in my hand. What would I do? I would traverse its neighbors. For auto neighbor in adjacency list of current, I need to traverse the neighbors. So what would be, how would I check if it's a visited neighbor or an unvisited neighbor? All I need to do is if distance from nearest source of that particular neighbor is equal to -1. What would that mean? It's unvisited. If it's unvisited, in the traditional BFS, what we used to do, we used to mark it as visited, right? But here now the distance would be distance of neighbor would be equal to distance of current plus 1 because it's one level ahead of the current node whichever you are taking. The neighbor would be one level ahead, like the distance from if the current wait, let me show you. Yeah, this was the graph, right? If this is 0, this is your current node. The distance of the neighbor would be current plus 1. If there's a one more node here, its distance would be, this would be taken as current. Okay, not here, wait. Uh, let's say it's somewhere here, there's another node. Its distance would be taken as, this would be the current node, and its distance would be taken as, current node has distance from the nearest source as 1. So this would have 2 because this distance is 1 and this distance would be another extra 1. So it would be equal to 2. So always current plus 1 is the distance of that particular neighbor. Coming back to the code. Okay, this is the case. And just like in traditional BFS, you would be pushing this neighbor. How would you push this neighbor? A push, q dot push nbr. Neighbor is successfully pushed to the queue. All right. So this is, let's see how this would work. Queue has 0 and 4. Current would be equal to 0. 0 would be popped out of the queue. What are zero's neighbors? Zero's neighbors are, see, zero's neighbors are 1 and 3, right? The direct neighbors are 1 and 3. So zero's neighbors are 1 and 3. 1 would be added here. 3 would be added here. 1's distance would be changed to zero's distance plus 1. Zero's distance was 0. So 1's distance would be 1. 3's distance would be 0's distance, which is equal to 0 plus 1. That's 1. And next, what would happen? The queue has 4, 1, and 3. 4 would be taken as current, 4 would be popped out of the queue, 4 would be popped out of the queue, and 4's neighbors would be added. What are 4's neighbors? 4's neighbor is 2, like the unvisited neighbor. We are marking already the unvisited stuff as visited, right? So this would get updated to 4's distance plus 1. That's 0 plus 1, which is equal to 1. Okay, and this 1 would be equal to current. 1 is already visited, so directly pop, no changes, no inserting of neighbors. 3's all neighbors are already visited, pop. 2, all neighbors are visited. Queue is empty, we get out of this loop. We are out of this loop. And now finally you need to return the distance vector. And you have successfully returned the distance vector. Once you have successfully returned it from here, it's getting stored here, the distance vector. And all you need to do is printing it. I would write a quick code to print it. Okay, done. This should be auto ampersand. All right. Everything seems fine, right? Let's try running that particular test case. All right, let's run that particular test case. It should be passing int n equal to adj dot size. N shadows a parameter. Okay, n is already existing, I guess. We don't need this line of code now. My bad. And it passed. If you see, it's printing the same result. So this was about multi-source BFS. Now let's apply this multi-source BFS to several problems on, say, lead code, maybe. So let's solve a problem on lead code. It's a popular problem. So this is the problem, guys. With this problem, we will be understanding how to apply the same logic on grids, like how to apply the same multi-source BFS logic on grids. The problem is very straightforward. You are given an m cross n grid where each cell have one of the three values. 0 representing an empty cell, 1 representing a fresh orange, 2 representing a rotten orange. Every minute, a fresh orange that is directly adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange left. Okay? If this is impossible, return -1. The problem is very straightforward. So let's understand how to apply multi-source BFS for this. First of all, let's understand why does it need a multi-source BFS? Why does it even need a multi-source BFS? So let's understand this as follows. So let me copy this image, paste it here. Okay. Now this this thing represents a rotten orange. This thing represents a rotten orange. Okay, let's use another color. This thing represents a rotten orange, right? This is already rotten. Fine. In the first minute, what would happen? These two adjacents would get rotten. Then, due to these two adjacents, these two would get rotten. And due to this would get rotten. This would get rotten. So how many minutes time did it take? It took equal to levels. This is level 0, level 1, level 2, level 3, level 4. It took equal to levels. So all you need to do is till here for this test case, you need to return the levels, which are essentially the what's a level? What's a level? A level is distance from the source. Source is at level 0. Its distance from itself is 0. The next level is at distance 1. The next level is at distance 2. After that, level 3, level 4. So it's essentially the distance from the source. Same logic which we are applying in the multi-source BFS thing. But you may ask me, there are no multiple sources in this test case. But when you come to other test cases, like the example 2, does it have a multi-source? No, it doesn't have a multi-source, but it could be any number of sources. Okay, if the grid's condition is like this, where say this is the grid, this is rotten, this is rotten, this is fresh, this is fresh, and the empty cells are empty. What would happen? You need to initiate a BFS from here, you need to initiate a BFS from here. So what would be the total time you would be taking? You would be taking 1 minute, just 1 minute, right? So this is what the problem is all about. You need to initiate a multi-source BFS. Uh, is it clear why do we even need a multi-source BFS here? If there are multiple rotten oranges, you cannot just return levels. Casually, you cannot just return levels. You should do something more. What's that? You need to consider multiple sources where the BFS starts from. I hope that's very clear. Why do we need a multi-source BFS here? Now, let's dig deeper into the problem. Let's take this grid only. How would it work? Okay, let me redraw it. Okay, so let's take this grid as an example. What are the two sources you would be considering? You would be considering this particular source and this particular source. And what you exactly need to do is distance 0, distance 0. Traverse the neighbors of this one, traverse the neighbors of this one. Mark the distance as 1, mark the distance as 1, mark the distance as 1, mark the distance as 1. And you need to maximize the distance value. You need to maximize the distance value. Why do you need to maximize the distance value? Because if you maximize the distance value, that would be the minimum amount of time taken to cover all oranges. See, if you only see, like if something to cover all oranges, it requires only 2. And sorry, let me come up again with this. Why you need to maximize is, if the maximum distance from source to the farthest orange, to the orange which is situated at the most distance, is some x, the farthest orange, let's call it farthest orange, the time taken would be equal to x. Time taken would be equal to x, right? So you need to consider the distance of the farthest orange from the nearest source. All right. You need to maximize that distance. That would be equal to the time taken. Is the approach clear? You need to initiate a multi-source BFS. You need to find the farthest orange and how far is it located. That's the problem if it's rephrased. Okay. So let's start writing code for this. So to implement the same logic we have done on adjacency list, on grids, you would need, since you are storing pairs of x and y, you would need a vector. You would basically need a matrix which stores the distance. All right. What would be the size of this matrix? The same as the size of the grid. So let's say the grid size is an m cross n. It's an m cross n grid. Int m equal to grid dot size, and int n equal to grid of 0 dot size, and let's write m. Initially it's -1. You can take any value. I took -1. You could take -2, -3, anything, just to signify that it's unvisited. Okay. Now we don't have a explicitly mentioned source array where all the sources are present. Instead, we need to find the sources. So firstly, let's make a queue. I would push the x and y values into the queue. So let me take a queue of pair and let me iterate through the grid. All right. Once you iterate through the grid, how do you know it's a source? If it's a rotten orange, then it's a source. Okay. So let's see, how do you find it's a rotten orange? If grid of I j is equal to 2, that means it's a rotten orange. That means rotten orange is a source. Yeah, rotten orange is a source, right? If it's a source, what would be the distance? Distance of ij would be equal to the distance from its nearest source. What's the nearest source? Itself is the nearest source. So the distance would be 0. Done. Now what would you do? Once after finding the distance, you used to push it into the queue. Push I comma j. Done. Once after finding all the sources, while queue is not empty, while your queue is not empty, just take the current node x comma y and q dot pop. Alright. Also let's make a variable time. Initially time equal to 0. Alright. Now we need to traverse the neighbors. In which directions? The question says we need to traverse the neighbors in 4 directions. What are the 4 directions? 4 directionally adjacent. That means not including the diagonals. Alright. Not including the diagonals. So let us make 2 vectors dx. One case is, let me simultaneously make the vectors. So the first case is moving upwards. Moving upwards. How would you move upwards? You can move upwards by doing a -1 here at the x. It would shift to the previous row. It would shift to the previous row. And if you do a +1, it would shift to uh, the next row. That means down. Next comes, if it's an up, y should be 0. Y is not changing. If it's a down, this should be 0. Now coming to left. Left is the previous y. Right is the next y. 0 here, 0 here. For left, right, the x won't change. Fine. We have made the directions. Absolutely fine. Now, int I equal to 0, I less than the 4 directions, I plus plus. What's new x equal to? New x equal to the current x plus direction, the dx, and new y equal to y plus dy. All right. And we need to check if they are out of bounds. Otherwise, it would cause an error. So let's check if they are in bounds. So let's write a function bool bound. We'll take int x, int y, int n, int m, int n. All right. Yeah. Return x is greater than or equal to 0. X is less than m. Y is greater than or equal to 0. Y is less than n. Semicolon. Yeah. Wait. Put 2 semicolons by mistake. Yeah. Now you need to check if the new x, new y which you calculated are out of bounds or not. So if they are in bounds, new x, new y, m and n. If they are in bounds, there are no cases of out of bounds. And if they are unvisited, how would you know it's unvisited? If distance of new x, new y equal to -1, that means they are unvisited. And if it's an empty cell, it's useless. If it's an empty cell, or else if it's already a rotten orange, then it's useless. You need to consider only the fresh orange. How to check it? It's a fresh orange. How to check it? Equal to 1. If it's equal to 1, then it's a fresh orange. In this case, what would you do? You would start your BFS from here. What would be the distance? Distance of new x, new y equal to distance of what we used to do? Distance of current plus 1. That means distance of x, distance of y plus 1. Alright. Once you do this, you need to maximize the answer, maximize the distance. So let's and time equal to that particular, you need to find the farthest fresh orange from the nearest source. So you need to maximize time equal to time comma maximum of time comma distance of mu x mu y. Okay, you need to maximize it. Let's rename it farthest orange distance. Okay, you need to maximize the farthest orange distance. You need to find the maximum distance that a orange has from its nearest source. Okay, after you do this, what would you do? You would continue the BFS by pushing it once again to the q dot push, sorry, nx comma ny, q dot push nx comma ny. Once you do this, your BFS thing is over. Then you would check. The problem says that, where's the problem? Yeah, the problem says that return the minimum number of minutes that we have already calculated that must elapse until no cell has a fresh orange. If that's impossible, return -1. Okay, so let's check. Let's do the possibility check because the problem demands it. It's not part of the algorithms till the problem demands it. Let's do a possibility check. Let's iterate through the grid, and yeah, we need to mark the grid of new x, new y is now rotten. That means it's equal to 2. Possibility check. Int I equal to 0, I less than n, sorry, I less than m, I plus plus. So int j equal to 0, j less than n, j plus plus. If you find grid of ij, if anywhere you see a fresh orange is left, return -1 because the BFS did not visit that orange. That means it's isolated. If it's an isolated orange, it won't get rotten, so it's impossible. This means orange was isolated and it's impossible to visit it via BFS. Otherwise, you can return that answer, which is the farthest orange distance. So let's see if this thing runs. And if it runs, let's submit it to lead code. So it gave a wrong answer, don't know why, wait. Let's see where's the error. Okay, this should be ny. That's it, simple. That was a typo actually. Yeah, I accepted. Now let's submit this. Done. Beats 100%. Nice.